Hello, in this video I follow my subdivision series, and we are going to observe this subdivision function inside the code. And first off, let's take a look what are the aims and goals in this program. This is a Tripscode program, and I just started up here. And I just enlarged this one a little bit, and let's open up an object file here. And this is a soccer ball object here, and I can scale it up in one axis, maybe x-axis, and I just now I apply subdivision several times, and we observe this cube went into a sphere, but the soccer ball looks like this one. And we could just apply also something like patches here to be more interesting with our geometry here. Just do a little selection here with polygons. And let's convert this selection into edges, and then I wish to convert it into vertices, and I just don't know if it works right now. Let's take a look what happened. We see this new curves were added to the geometry, and those curves then dictate the shape for the object. And after we have applied those curves, then we can add the curve weighting. For this we need to be in curve mode and in object mode, and Shift E, and I just add a little bit weighting for those curves, and I get rid of this polygon selection with escape, and zoom in and observe this new shape. Here we have that some curves are missing, then this shape is rather not so well defined. And we can also switch between patches modes with Alt-B. For this program to work correctly, we need to be in English keyboard. And we see here we get the better definition, but we here lack something of the definition. And I go into edge mode and I press escape to get rid of the edge selection, and I just try to make new edges selection here. And those curves don't need to be closed, they just need to be and I press C to convert into vertices, convert those edge selection into vertices, and then I press Ctrl P to add this curve. And what we see here, we see that this curve right now has no weighting to it, but here it rather skips. And for this to fix this, we need to be on curve mode and in object mode, and Shift E, and we just apply this weighting this way, and we come up with a better shape for our possible meteorite or alien spaceship or whatsoever we wish to visualize. And this we see here what effect those curves have on the object. And now just I don't want to lose this object, I export it here. Before exporting, I can give it a new name also here. Just I edit name and press enter, and this way. Or I could also save this file, but right now I just close this up. Yeah. And let's take a look at this code, what we have here. And we saw that the pronounced effects come up with rather higher subdivisions, but let's observe in this code the very first subdivision level, and I have a little drawing also here what subdivision means. And we see here that we observe a pentagon shape, and essentially subdivision adds central polyvertices and edge central vertices here, and those vertices then are moved. When we have a Catmull-Clark subdivision, then this central polyvertice remains intact, and other vertices get new positions. When we have patches, then patches, in the case of patches, those cage vertices, all the old vertice analogs, they remain in place rather, and this central vertice and edge vertices acquire new positions. And when we get a mix of it, then the algorithm decides where certain vertices need to go. But when the subdivision creates this geometry and the connections, but different function gives them initial positions, and the initial positions lie in mathematical mean lines for those edge vertices, and the average position of those vertices is the central position here. And this being said, let's take a look at this function here, tune in subdivision shape transformed. This is for level 0. Unsubdivided object is level -1, and the next function is tune in subdivision shape transformed underscore, and this underscore version is for next subdivision levels, and is far more longer and more complicated, because it needs to navigate proper points inside a patch. And this function starts here, and first off it deals with edge vertices, those new edge vertices here, and with it counts edges, indicates those edges with E, and V means vertice, and this then is the edge vertice, and it is indexed with vert count plus edge counts. So in the arrays those element types are organized in a strict fashion. For instance, when we speak about vertices, then cage vertices remain intact. Then to the array are added edge vertices, and finally in the end of the array are the polyvertices, those central vertices. And we just slightly explain what this function does, and I point out those sections that we can skip because they deal only with patches, and here we see that those sections are patch related, but when we go into different case that we come up with subdivision, Catmull-Clark subdivision, and edge weighting or open edges, then we get those the next section here. And here it deals with those edge vertices, and then we have a section that deals with a case when maybe patches are in the object, and patches defined then when at least one curve is along the polygon border, and we can collapse this one here. And we see for the Catmull-Clark subdivision we then handle corner vertices, and if we see corner vertices, then here this section also relates to the patch, meaning this control point belongs to a curve, and then the edge this according vertex acquires the position for the curve vertex for this control point vertex. And if we skip this one, then we get those Catmull-Clark subdivision here, and we are going to scroll gauge vertices, and with open curves those edge vertices. Let's take a look at the drawing. When we get this open curve case, for instance, then those edge vertices. Let's imagine that this is empty polygon and the geometry lies around it. Then those edge central vertices remain intact in their original positions, in the mean positions here. And those cage vertices become manipulated to come up with more ring-like shape inside this polygon. Alright. And the same thing happens when their edge weights are applied along the edges. This is also a possibility in this program. One can argue that those curves really are like edge weights, but not curves include additional features in them. We can manipulate the shape of the curve and make a more corner vertices in the curve, and adjust the vertice weighting inside the curve, and this affects the shape of the object there. Also very interesting shapes can be possible. And we see this then those gauge vertices are scrolled with vert count, and we see here two types of vertices are acquired. The V points to the new zeroth subdivision, and V null is the previous subdivision, meaning unsubdivided geometry. And those indices are the same because the the vertice data for the cage vertices precedes the other types of vertices, meaning the edge vertices and the polo vertices. And we see here that the cage vertices are scrolled, and they are, in the Catmull-Clark case, those cage vertices acquire new positions. For instance, if we observe a cube, then this cube becomes ball-like with further subdivisions, and the unmoving points are the polovertices, meaning the new ball shape forms inside this cube. And this means that cage vertices and edge vertices are manipulated into new positions. And let's take a look how it looks like here. We populate various areas and later to variables, and we handle also the open edge and edge weighting cases here. And here we use this Catmull-Clark formula, and we also get the possibility to add vertice weights for individual vertices. This is also mixed with edge weights, so you get also vertice weights in this algorithm. And this was for the first subdivision level, meaning this is the subdivision level 0.